Good morning, everyone. Today we're going to be looking at Unit 5, Lesson 15, and our job will be to really review the volume of prisms, cylinders, cones, and pyramids. So let's do a quick recap. We started with volume of prisms, and that was just the area of the base times the height. That's why we use capital B. And then we looked at cylinders. Now remember, a cylinder is just a prism with a circular base. So the only thing that would change is the area of the base is pi r squared. And then we said, prisms, if I took a triangular prism and I cut it into 3 equal solids, that would give me one pyramid. We did that in activity 12.3. The volume for any pyramid is just 1/3 the area of the base times the height. And then we said, a cone has a circular base. So the only thing I'm going to do is change the capital B here into the area of a circle. So 1/3 pi r squared times the height. So hopefully you're not really looking at this as 3 or 4 separate formulas. You're thinking they all came from the volume of a prism. All right, let's use those here today. Our job is to look at these as a review for this lesson. What I'd like you to do is press pause, and on page 313, go ahead and record your answers and try to do this mentally. See if you can get the answer, find the volume of each solid mentally. Hit pause, and when you're ready, hit play. All right, now that you had a chance to do that, let's go some of the answers here. I actually showed my work even though we were supposed to do this mentally, but I noticed that I have a triangular base, 3 by 8 right triangle, so 3 times 8 is 24. Half of 24 is 12, and the height is 10. So 12 times 10 would give me a volume of 120 cubic units. Now I have a cone. I'm thinking the cone is 1/3 the area of the base times the height. So the area of the base is 5 squared times pi, or 25 pi. 25 times 1/3 times 6. Well, 1/3 of 6 is 2. 2 times 25 is 50. So you should have got 50 pi cubic units. I prefer to leave it as 50 pi. One, we're doing this mentally, so it'd be challenging to times that by the full decimals of pi. So leave pi, we call that an exact answer. All right, well notice that next one has the exact same base. So I know that the area of this base is 25 pi. 25 times 8 is just 200. And then over here, we've got a 4 by 3 rectangle as the base. So 4 times 3 is 12. It's a pyramid, so I'm going to divide that by 3. So 12 divided by 3 is 4. 4 times 6 is 24. However you do that, but hopefully just you can kind of check your answers here. Go ahead and hit pause if you need to review any of these at greater detail. All right, the next thing we'll do is turn to page 314. We're going to look at what's called missing measurements. These are when the problems get a little more challenging. So let's look at part A. Which measurements do you need to calculate the volume that isn't given? So let's start with the cone here. We need a height. We have the height of 7. I need the area of the base, and I need to find the radius. So the radius is the missing measurement for part A. In part B, I have the base, which is a rectangle, so I can find the area of that. I need the height. The height is indicated by the perpendicular length from one base to the next. So we're missing the height on this one. And that question then is, can you find them? So go ahead and see if you can find the radius for the cone and the height of the oblique prism. All right. You can hit pause. If you didn't hit pause, please do so. Let's go over this. So notice here on the cone, I have a right triangle between the slant height, the height, and the radius. So I'm just going to actually kind of draw that separately. And I'm thinking I've got 7, 8, It's a right triangle in the radius, so the radius squared plus 7 squared equals 8 squared. Go ahead and solve for r, and you get r being the square root of 15. Leave this as the square root of 15. It's more exact. You'll see why later on, why it's beneficial to leave it as the square root of 15. All right, the next one, if you notice this, it forms a right triangle, and we have a 65-degree angle between kind of where the base is extended and the slant of the oblique prism. So what I did is I just drew that separately, and instead of h, I called that x, because I didn't want to get h mixed up with hypotenuse. And I should probably put a 90-degree angle in right here. So we have a little trig review. The 3, the distance of this dotted line, is the adjacent side. The 65 across from the 65 is the x, and that's the opposite side. So I'm thinking SOHCAHTOA, TOA. And I have O and A, so I'll set up the tangent ratio. Remember, tangent is the opposite over the adjacent. So tangent of 65 equals opposite over adjacent. I like to put that over 1, and then I'm thinking cross multiply, right? 3 times the tangent of 65 equals 1 times x. Grab your calculator, plug this in, make sure you're in degrees mode, and you should get the height, or x, is 6.434. Okay. Part C, I kind of skipped. It says, which volume formulas will you apply? I'll actually do that as I solve part D. But if you'd like to, or what you should, is go ahead and hit pause. And now with our new measurements, go ahead and find the volume of each solid. Okay, now that you've had a chance to try it, let's go through and work through it. Now, first thing is I have a cone. The volume of a cone is 1/3 the area of the base times the height. So I have to find the area of the base first. I know the height is 7. The area of the base is pi r squared. So if I take the radius and square it, here's why leaving it as a square root of 15 is beneficial. If I plug the square root of 15 in for the radius, 7 in for the height, notice the square root and the square root are going to go away. And then I'm left with, oops, that's not supposed to be there. I kind of did 2 steps in one here. I said, okay, well, the square root and square root go away, and I have 15. Well, 15 times 1/3, or 15 divided by 3, is 5. 5 times 7 is 35 pi. I would prefer my answer to be written as 35 pi, but if that's a multiple choice and it's written as a decimal, I do 35 times the button pi in my calculator. I like to round it to 3 decimals, even though they say round to the nearest tenth. This is a little more accurate. All right, the next one, let's go ahead and solve this one here. We have the oblique prism, which we're going to use the area of the base times the height. Now remember, the area of the base here, the base doesn't always mean bottom. You have to be careful with that. I decided to call this the base, and the area of the base is the rectangle that's 7.5 times 4.5. So here's my area of the base. The height was what we calculated using tangent, and when I just multiply all of those together, actually I think I decided to do the area of the base first, and then I times it by the height. But you should get 217.148 meters cubed. All right, page 314. Number 2, we'd like you to calculate the volume of each solid, rounding to the nearest tenth. You'll notice we do have a missing piece here that you'll have to find. So go ahead and hit pause, and you can work through this one. All right, now that you had a chance to do that, let's take a look at what we need. First question is, always, is what is the base? Right? The base, in this case, are the 2 congruent triangles. Right? I've got one on top, one on bottom. It doesn't matter, but I want to think of one of them as the base. So what I'm going to do is actually calculate, I'm going to draw that out. I just redrew the base. I took the bottom here, redrew it. It's a right triangle. See the 90 degrees up top? So we have a 48 length, an unknown length, and we know the hypotenuse is 73. So 73 squared minus 48 squared, or I should say 78 73 squared equals 48 squared plus x squared. Solve for x. Right? So I'm going to square those, subtract 2,304 over to the other side, take the square root, and we get a friendly length. This length right here for x is 55. And since it's a prism, it's the area of the base times the height. Now the area of the base is the area of this triangle right here. So it's 1/2 base times height. Well, the base is 55. The height on the triangle is 48. And then the height of the solid is 33. So I did the base first. I ended up getting the area of the base is 1320, the height of 31. Multiply those together, and you get 4,920 centimeters cubed. All right, part B, this one's fun. You'll notice we don't know the height nor the radius. We have to find both the height and the radius. All we know is we have a 30, 60, 90 triangle, and we know that the side length is 10. So what I'm going to do here is I just redrew this triangle. And I could have added one more piece here. Notice this is a 60 degree. Now, you do have the option of doing SOHCAHTOA if you would like. But I noticed that this was a 30, 60, 90 triangle. And I know that across from the 30 always has a formula of x. Across from the 90 is always 2x. And across from the 60 was always x square root of 3. So look at how quick this is now. Well, if 2x equals 10, that means x had to be 5. So if x was 5, that means the height is 5. And if the radius is x squared of 3, that means the radius is 5 square roots of 3. So I might add that back up to my picture just to make this easier for us to see. And then I can actually calculate the volume. Now notice it's a cone, or cone. So I've got 1/3 the area of the base, which is pi times the radius squared. But I know that my radius is 5 square roots of 3. And then the actual height. The height is what we found over here as 5. And then we're going to go ahead and show you a quick little property here. I have to square everything inside of the parentheses. So 5 squared is 25. The square root of 3 squared is 3. And then the 5 drops down. Now notice one thing here. If I have a 1/3 times by 3, the 1/3 and the 3 go away. And I'm really just doing 5 times 25, which is 125 pi inches cubed. And I would just leave it just like that. All right, 5.3. Suppose this two-dimensional figure is rotated 360 degrees using the vertical axis shown. Each small square in the grid represents 1 square inch. Draw the solid that would be traced out and label the dimensions if we rotated around the vertical axis. So what I like to do here is just draw what would it look like if I reflected, and I usually take the friendly point. So this point would be reflected over 2 units to the left. This one will be as well. And I would have this outline if it was just completely mirrored over to the other side. However, it was reflected or rotated. So we're going to come off of our page, kind of have this view 3-dimensionally of what it would look like. It kind of looks like a short pencil that has a rounded spot. Okay, label the dimensions. So now we have to label radii, diameters, whatever we need to solve this. So I'm going to start here and say the radius is 2. Now I notice that this is a cone, 1, 2, 3, with a height of 3. And I'm thinking of this bottom part being the base. So up top I've got a cone. And then on the bottom, the second solid still has a radius of 2, and its height is 1, 2, 3, 4, 5 units long. All right, so label the dimensions of the solid. We have all the dimensions. Find the volume. So I'm going to draw a little picture here that'll help me out, I think. All right, so I need to find the volume of this solid, which is really comprised of two solids, a cone and a cylinder. So here's what I did. I like to draw what I call a picture equation to help me kind of view what I'm doing and keep everything straight. So I want to find the total volume of this solid, which is made up of the volume of the cone plus the volume of the cylinder. So I split it up. I also wrote the dimensions of the cone. It has a radius of 2 and a height of 3, as we discovered up here. And then the volume of the cylinder with a radius 2 and a height of 5. So I'll start. The volume of the cone is the area of the base times the height times 1/3. Well, notice the 1/3 and the 3, those are going to go away, right? 1/3 and 3 reduce out, so I'm just left with 2 squared times pi, or 4 pi. And then over here, I have the area of the base, which has the same base, so that's 4 pi times the height of 5, which is 20 pi. So I get area of the cone, 4 pi, area of the cylinder, 20 pi. If I add those together, I get 24 pi inches cubed, and that will be the volume. That's the exact answer. It does say round your answers, so you could do 24 times your pi button and round it if you need to. All right, let's take a look here. So, in general, what dimensions are needed for the volume of a cone? Well, here's the way I think of it. Volume of a cone is 1/3 the area of the base, which is a circle, times the height. So what do we need? Anytime we have a height and a radius, those are the quick ways to find it. However, they could give you certain things like this. Let's say I have a cone and they give me the slant height and they give me the height, right? I could also find something if I know a number right here. I could use Pythagorean theorem. I could even use trig if I know an angle measure here, right? Or up here. I could use 30, 60, 90s as we saw. So it's not just limited to the height and the radius. We could give you other items and you could work backwards to find those items. What formulas are used when calculating the volume of a triangular pyramid? Well, a triangular pyramid, right away I'm thinking volume is 1/3 the area of the base times the height. But the base is a triangle. So I want to actually substitute in, instead of base, I know the base of any triangle, the area of the base is 1/3 base times height. You have to be careful. This height is the height of the solid. This height is the height of the base. So if I drew a quick little triangular pyramid, sorry, this is a prism. Let's say I had this solid right here, and that was a 90-degree angle. So the base and the height, and then the actual height of the solid, you just be careful between those two. What's the difference between capital B and H in the triangle area and the B and the H in the pyramid formula? So that's what we just talked about. More specifically, the lowercase h and b, those are for the base only, and the capital B is the area of the base, and then the H in the formula is the height of the pyramid. And then what formulas are used when calculating the volume of a cylinder? Kind of already reviewed that, but any volume of a cylinder is area of the base times the height. What makes the cylinder special is its base is always pi r squared times the height. So you need a height and a radius. All right, homework tonight. If you guys could, please go ahead and read through the summary on page 316. Complete the problems 1 through, I believe it's 1 through 7, not 87. It might be 1 through 8 on page 317. Check your solutions online. Don't forget Delta Math. Week 3, you can start that. And then do quiz corrections if you haven't already. All right, I will see you guys soon. Have a great day. Adios.